Welcome. Today, we're going to demystify the world of statistics. We're going to break it all down and turn it from this intimidating math class you might remember into a really practical, powerful tool for understanding the world all around us.
Okay, let's just dive right in. Think about it. How can a few thousand phone calls possibly predict how millions of people are going to vote? And how can one person use the word average to prove a point, while someone else uses the exact same data to prove the complete opposite? You see, statistics isn't just about crunching numbers. It's a method for answering really big questions, and sometimes for twisting the truth.
And believe me, this stuff is everywhere. Thanks to powerful computers, statistics have kind of worked their way into the very fabric of our daily lives. From the pollsters trying to win your vote, to sports analysts trying to pick the next champion, to stock traders trying to predict the market, these tools are shaping our world in ways we don't even see.
At its core, though, it's all about a pretty simple process. It really is. It starts with a clear question you want to answer. Then you go out, you collect the data, and you use statistics to find the answer. It's a journey, really, from curiosity to conclusion.
Every single statistical study starts with its raw material, its fuel, if you will, and that's data. We're talking numbers, measurements, opinions, sales figures, but where you get that data and how you collect it is probably the most critical factor of all. The quality of your data, it's everything. Now, it's pretty much impossible to survey an entire population, right? You can't ask every single voter in a country for their opinion. It would be chaos. So instead, statisticians rely on a much smaller group, a sample. But here's the catch. For this to work, that sample has to be like a perfect miniature version of the whole group, and getting that part right is absolutely crucial.
And to see what happens when that sampling goes terribly, terribly wrong, let's take a look at one of the most famous blunders in the entire history of polling. Now, what's really wild about this is the sheer size of the poll. 10 million questionnaires, that's huge. But look at who they asked. This was 1936, right in the middle of the Great Depression. The people who could afford magazine subscriptions and cars and telephones, well, they were, on average, a whole lot wealthier than the rest of the country.
And of course, the result was a complete disaster for the magazine. This is a perfect illustration of a fundamental rule of statistics. A biased sample will always lead you to a wrong conclusion, no matter how massive that sample is. It just wasn't random enough, so it was completely, totally wrong.
Okay, so let's say you do it right. You get good, unbiased data. Now what? How do you actually make sense of it all? How do you find the story that's hiding inside that big pile of numbers?
Most people just use the word average. But in statistics, there are actually three common ways to find the center of a set of data. You've got the mean, the median, and the mode. And as we're about to see, each one of them can tell a very, very different story.
Let's make this real with a really fun example. The salaries for all 434 NBA players back in 2017. When we look at the different ways to calculate the average, a really surprising and kind of complicated picture starts to emerge. So first, you have the mean salary. That's the one we all learned in math class, right? You add up all the salaries, divide by the number of players, and you get this whopping $7.1 million. Now, this number is heavily skewed by the massive contracts of just a few superstars, so it paints a picture of incredible wealth for pretty much everyone. But then there's the median. Okay, so if you lined up every single player from the lowest paid to the highest paid, the median is the salary of the person standing smack dab in the middle. At $3.4 million, it tells a much more grounded story. It's less than half of the mean. And finally, we have the mode. This one is the easiest. It's simply the most common salary in the entire league. And back in 2017, that was around $1 million. This reveals what a really large number of players, often the ones on those minimum contracts, are actually earning. So here's the crucial point. Someone could honestly stand up and say the average NBA salary is $7.1 million, while another person could say it's $1 million. And here's the crazy part. They're both technically correct. It all depends on which average they choose to highlight, which is exactly why this famous quote is so perfect. So how does all this come together? Let's move on and see how statisticians actually use this data to formally test an idea or a claim, or what they call a hypothesis. A really brilliant way to think about this process, called hypothesis testing, is to compare it to our legal system. In a courtroom, a defendant is presumed innocent until proven guilty, right? The prosecution has to present overwhelming evidence. Well, in statistics, an initial claim, what's called the null hypothesis, is assumed to be true. You need to gather strong enough data to prove it's false.
And this gives you a really clear, logical framework for the whole thing. You see, you start with a question. Then you state the default assumption. That's your null hypothesis. And then you state what you're trying to prove instead. From there, it's about picking the right tools and setting the rules of proof before you even get to a conclusion. It's a structured way to stop you from just finding whatever you want to find in the data.
So, we've gone on this whole journey. We've gone all the way from just asking a simple question to gathering good data, analyzing it, and then finally, reaching a conclusion.
Understanding these basic concepts is like a superpower in today's world. It really is. It empowers you to be a more critical, more informed consumer of the data, the news, and the ads that you see every single day. So the next time you see a statistic, don't just accept it at face value. Ask the questions. Ask, who did they sample? Was it biased, like that 1936 poll? Ask, which average are they using? The superstar mean, the everyday median, or the most common mode? Because asking those questions, well, that's the true power of understanding statistics.